Okay, so to do today's work, what you're going to do is you're going to open the assignments um, and go to the instructions or details part of it. And there you'll find the Google Doc as well as the link for the website. So once you open the Google Doc, it'll link to a document that looks like this. And in this document, it shows you it gives a definition of what a model is. So the website that we're going to be using today it's a model of something. Um, it gives you the link for the website as well. In addition, it gives you some definitions that you're going to need to know while you're doing the lab. So I suggest that you read through those because it just gives you a quick overview of what the words on the website mean. When you scroll down to where it says procedure, you're going to see, again, there's going to be a link for the website, and then there are going to be settings that you need to click on in order to do the lab properly. So I'm going to open the link. When I open the link, it brings me to this page right here. And so the first thing that it tells me to do is under general settings, I want to click show sun's declination circle and show stick figure and its shadow. So I'm going to go over here to where it says settings. It's already clicked the sun's declination circle, but I'm going to unclick show the ecliptic, and I'm going to unclick show the underside of the sphere. You can have these if you want to. You don't need to. Or the ecliptic, remember the ecliptic is just the path that the planets and their sun move in, that flat plane line, as well as the constellations, the zodiac constellations. So I'm going to unclick that. And the next thing I want to do is I'm going to go under animations control. I'm going to hit continuous loop date. I'm going to set the speed to 2 hours per second. So continuous is already clicked. I'm going to hit loop day, and then I'm going to bring the speed down to 2 hours per second. All right. And then finally, I'm going to scroll down. I'm going to go to time and date locations, which is up here. I'm going to set my latitude to 41 degrees, which is around where New York is. I'm going to set my time to 12 a.m. midnight. And then I'm going to move the date. So we're going to be starting with spring. So I'm going to move the date back to March 21st. You can also just like type it in. All right. And once you do that, March. Once you do that, it'll bring, that will give you the settings that you need to start with. So the next step is to go through each season. So like I said, we're going to start with spring. You've already moved the date to March 21st. It says play the animation through several times to see the path of the sun in this date. So you're going to hit start animation. And once you do that, it'll play through what the sun looks like throughout this season. All right, so you'll notice that the sun is going rising in the east and setting in the west. And as it's doing that, there's a shadow on the figure, and the shadow changes directions depending on what direction the sun is facing. And so once you've played the animation a few times and get a sense of the pattern that's happening, we're going to go back. I'm going to answer these questions. So you're going to hit stop animation. And you're going to go through the first questions. All right. So here it says deposit at sunrise, sunset, and solar noon, which is the highest position. So we're going to go to A, which is the location of sunrise. So you can also drag the sun back. So, oops, don't want to do that. Maybe I'll just hit start animation. All right, stop. I'm going to actually bring the sun back a little bit more. Maybe I'll just move it around so I see where it's at. That's weird. Okay, stop it. So technically I'm having technical, maybe we'll just move the time back. So, all right, so sunrise is just when the sun comes up at the horizon. So that's around 6:09, right? And that makes sense because the sun, if if you're up at 6 a.m., the sun is just coming out. And so if I look at the directions, I see that it's rising in the east, right? So I'm going to hit due east. So due east just means that it's in the east, directly in the east. Obviously, north of east is just north of east, and then south of east is south of east. And the sun isn't up enough right now to see the shadow, but once if I bring it back a little bit more, there's a little shadow, right? So the shadow right now is pointed in the, I would say, northwest direction, or so it would be north of west. Right? And you're going to go through that. So if you bring it back, if you move the time to sunset, do the same thing. And then you're going to move the time to around 12 o'clock is when it gets to the highest point. So, oops. And the way that you can tell what the highest noon point is if you look at the sun's altitude. So the sun's altitude is it's the essentially like the elevation above the horizon. So when you look at, if I play the animation, you're going to look for when that number is the highest number. So I think it gets to around 48. That's probably the highest. So at 48 would be when it would be high noon, right? The highest point would be 90 degrees. That's the sun's altitude would be directly above us at 90 degrees. But the only time that ever happens is in June in the northern hemisphere. And it doesn't happen at 41 degrees. It happens at where the sun is facing directly at the earth. And so that would be at 23.5 degrees. And so if you start the animation again, you'll see that that number gets up to around 90 degrees. Yeah. So it gets like 89, I think is what it was. I'm going to move it back a little more. Boop. So 89 degrees, pretty close to 90. So the only places that you'll get the sun directly at 90 degrees, which is directly above you, would be at 23.5 degrees north in our summertime, and then 23.5 degrees south during the winter time. It will be directly above in the winter time. If I move this over, so you can feel free to play around with these variables, and if it helps you get a better understanding of what the sun's path is like.